तनिष्का, तो तुमने फिर वो लोहड़ी वगैरह मनाई थी क्या कल परसों? तुम लोग क्या करते हो मकर संक्रांति के दिन? हेलो हेलो हेलो।
यस सर।
क्या करते हो मकर संक्रांति के दिन? कुछ किया?
फिर हमारे कल थी मकर संक्रांति मेरे यहाँ। हमारे यहाँ पे घुघुते बनते हैं।
हाँ, पतंग वगैरह भी उड़ती है क्या?
हाँ, उड़ती है।
उड़ाई थी?
नहीं।
सर्दी इतनी हो रही है, पतंग उड़ाओगे कि या फिर वो करोगे?
ऊपर से पोल्यूशन भी है।
हाँ, आती है पतंग उड़ानी? नहीं आती?
नहीं सर, पापा उड़ा के देते हैं।
मेहनत बहुत मेहनत बहुत लगती है। एक बार तुम
सॉरी सर।
उसमें मेहनत बहुत लगती है।
हाँ सर।
एक बार आप उसको उड़ा दोगे ना, फिर उसके उड़ाने के बाद उसको बैलेंस करके ऊपर लेके जाना, फिर उसके बाद तो फिर वो सेट हो जाती है।
हाँ।
चलो स्टार्ट करते हैं ना। ओके।
ओके सर।
Now what we are going to study is this Carnot engine. The basic, all the processes which were there, we have already completed. Today we'll try to complete Carnot cycle. Carnot engine. It's an engine which is supposed to be having the highest efficiency. Engine with the highest efficiency achievable, which is actually, if we say 100% efficiency of an engine, it's actually not possible because there will be losses, friction losses and all. Engines, where they are used, car, motorcycle, everywhere engine is being used. But the 100% efficiency is very difficult to achieve, but the maximum possible efficiency that we can achieve in an engine is using this Carnot cycle, Carnot engine. Okay. Today we'll discuss this Carnot cycle. Then actually one more concept is left after that is entropy. If possible, I'll try to cover that because it's a very small concept. Questions based on that I'll teach you in the next class. Now, first, understanding the Carnot engine, we need to understand the efficiency. What is an efficiency of an engine? Efficiency of an engine is defined as the total work done, W net, in a cycle, all divided by heat absorbed. This is the formula, this is the basic formula of efficiency of a heat engine. Now, once you know this one, actually, let me draw the Carnot engine. Actually, in a cycle, whenever we have a cycle like this, or a process which consists of 4 different processes, in this either there will be work done, W1, W2, work done on the process, work done by the process is W2, Q1 is the heat absorbed, Q2 is the heat released in the process. Then in such cases, because we know if we apply dq is equal to du plus dw, You know, in a cyclic process, earlier we have learned in a cyclic process, the total internal energy change is zero. Delta U in a cycle is zero because it's a point function. It depends on the points, initial and final points. And when you are starting from a point, you are again reaching to that point. That's why the property of point function, the total change is zero. That's why delta U in a cycle is zero always. Now what we learned here, delta Q is equal to delta W in a cycle. So the total work done, I can write as delta Q, which is Q1 minus Q2, because Q1 is positive because it is being absorbed in the process. Q2 is negative, it is lost from the process. So in a cyclic process, what I can say is total work done is equal to Q1 minus Q2. So this formula of efficiency, I can write efficiency is equal to W net divided by Q1 heat absorbed, or I can write this as Q1 minus Q2 divided by Q1, or simply I can write this as 1 minus Q2 by Q1. These are all the possible formulas for an efficiency of an engine that we can write. Correct? Now comes to
Okay, sir.
your Carnot cycle. What are the four processes which are involved in a Carnot cycle? Once we know, then we will be able to find out its efficiency. This is P, this is V. This process, it's moving from 1 to 2, then to 3, then from 3 to 4, then from again 4 to 1. That's the process. Now, this process 1 to 2 and 3 to 4, these two processes are actually isothermal process. 1 2 comma 3 4, and 4 1 and 2 3, these processes are adiabatic process. Okay, this is the thing. Now since 1 2 process is an isothermal process, that means temperature is constant. I'll put T1 is the temperature of process 1 2, and the temperature of process 3 4 is T2. Because they are isothermal process, temperature should be constant in whole of the process. Now since 1 4 comma 2 3 are adiabatic process, that means delta Q is 0. No heat absorbed, no heat loss will take place. Correct this one, because that's the basic definition of adiabatic process, right?
Okay.
we know the efficiency, the formula is W net divided by Q1, or I have written Q1 minus Q2 by Q1, or simply 1 minus Q2 by Q1. So to find out the efficiency in this process, I'll make use of the formula efficiency is equal to 1 minus Q2 by Q1. Now, we need to understand in which process heat is being absorbed and in which process heat is being lost. Can you think of something? Can you tell me in which process heat is being absorbed and which process heat is being lost? While defining, I have told you earlier, Q2 is the heat lost and Q1 is the heat absorbed. But in this process, which process of 1, 2 and 3, 4, which process is losing heat and which process is gaining heat?
I guess Q1 is gaining the heat and Q2 is losing the heat.
Which process? 1, 2, process 1, 2 is absorbing the heat, or process 3, 4 is absorbing the heat?
Process 1, 2 is absorbing the heat.
Who can you tell?
Hmm, exactly, not sure.
Let me tell you. That is for sure. Either the heat exchange is being taken place in the process 1, 2 or 3, 4. Yes, in the process 1, 2 or 3, 4, if we take process 1, 2, we know delta Q is equal to delta U plus delta W. Correct? But delta U is what? Then CV delta T. Correct? But temperature is constant in the process 1, 2, isothermal process.
Okay, sir.
So this is 0. Still, you have not got the answer. Delta Q is equal to delta W. But if you remember, do you remember what's the value of the work done in isothermal process? It's NR T1,
NRT.
NRT ln V2 by V1. No? You remember?
Sir, not exactly, but I guess it's NRT.
This thing we have derived actually. Let me show you. I think you were absent in that class. That's why you do not remember properly.
Yeah, I was absent in 3 classes.
When we were studying chemistry, then also you actually we did not reach till here. The isothermal process temperature is constant, and I told you I derived the work done, and work done was delta W is equal to nRT log V2 by V1. Now you remember.
Yes, sir.
And work done is this, but because delta U is 0 in this process because temperature is constant, so we can write delta Q is equal to delta W. So delta Q becomes equal to delta W. Formula is nRT log V2 by V1 when the process is moving from 1 to 2. Correct? Now coming to our
Okay.
question. Here, delta Q is nRT log nRT1 log V2 by V1. But if you see properly, the volume V2 is actually greater than V1. V2 is greater than V1. So the value of log is positive. So delta W nRT1 log V2 by V1 will be positive. That is delta Q. So the value of delta Q is coming positive. That means what? It's absorbing. Now you understand?
Yes, sir.
The heat is being absorbed here, Q1. Now if you Similarly, if you analyze this one, V3, V4, I'll show you how the heat will be lost. Now coming to process 3 to 4, again delta Q will be equal to delta U plus delta W. But again the process is isothermal 3 to 4, so the delta U will be 0. Delta Q is equal to delta W, and that is equal to NR T2 ln V4 by V3, because the process is moving from 3 to 4. But here V3 is greater than V4, so I'll make V3 above. So delta Q will be equal to minus nRT2 ln V3 by V4 I can write. When I take the reciprocal, I'll have to put minus 1 above, and I take minus 1 outside. Okay, now you know the logarithms. Correct, Kanisha, or you want me to tell?
So can you tell one time about the log?
There is a property when log of x power minus 1 is there, that minus 1 comes outside, minus 1 log x. Correct? Now what I am doing is, suppose I have log y base a. I can write this as log y power minus 1 whole power minus 1. Correct?
Yes, sir.
So I can write this as log base a, y power minus 1 is 1 by y whole power minus 1. So minus 1 will come outside, minus 1 log 1 by y base a. Now here I had v4 by v3. What I did, I tried to write this as nr t2 ln 1 by v4 by v3 whole power minus 1. Minus 1 will come outside, minus 1 came here, and 1 by v4 by v3 is v3 by v4. Understood?
Yes,
Actually,
sir.
this is the property. That means what? Here from 3 to 4, heat is being lost. Delta Q is negative, means it's lost. And what is the value of the heat lost? It's this. What is this? Today I think Haripriya slept. Why it is hanging? अरे just let me close it once. Restart. So what I was doing, heat is lost. This is Q2. So this is the value of Q2. Q2 is equal to minus nRT2 ln V3 by V4. Correct?
Yes, sir.
Now this negative sign shows it's being lost. So quantity wise, I'll just put it as positive because I know the heat has got lost. Now it's okay. Now efficiency formula that we had was this. Efficiency is equal to 1 minus Q2 by Q1. So I can write here 1 minus Q2 is nRT2 ln V3 by V4 divided by nRT1 ln V2 by V1. nR and R you can cancel out. So the efficiency is becoming 1 minus T2 by T1. Still there is a room for cancelling out. I'll tell you how. Divided by ln V2 by V1. Now compare this one. See, the process 2 to 3 and 1 to 4, they are adiabatic process. Yes.
Yes.
Now in now in the adiabatic process, we know what's the relation between T and V. TV power gamma minus 1 is equal to constant. So from 2 to 3, at 2 the temperature is T1. So I can write like this. See, T1 V2 power gamma minus 1 is equal to, at 3 temperature is T2, T2 V3 power gamma minus 1. Look very carefully this one. At 2, adiabatic process TV power gamma is constant. 2 to 3 is an adiabatic process. At point 2, the temperature is T1 because whole process 1 to 2 is isothermal. T1 will be constant throughout. Volume is V2 at 2, T1 V2 power gamma minus 1. And at 3, the temperature is T2 because it's part of the isothermal process. 3 to 4, T2 V3 power gamma minus 1. Clear? Karishka?
Yes, sir.
After this, I'll end. Now from 4 to 1, if you go, again you can write the from 4 to 1. That is T2 V4 power gamma minus 1 is equal to, at 1, T1 V1 power gamma minus 1. I'll write it here, bottom. We have T1 V4 T1 V2 V2 power gamma minus 1 is equal to T2 V3 power gamma minus 1. Also, T2 V4 power gamma minus 1 is equal to T1 V1 power gamma minus 1. This is only relation, no? Let me check again. Now see, if I write it like this, T1 V1 power gamma minus 1 is equal to T2 V4 power gamma minus 1. And just divide this equation 1 and 2. Divide 1 by 2. What you'll get? V2 by V1 power gamma minus 1 is equal to V3 by V4 power gamma minus 1. Correct? So from here I can write V2 by V1 is equal to V3 by V4. So these two are getting cancelled out. So what's the final efficiency you are getting? There is a problem. Let me just find out this efficiency formula and let's end it. So this and this will be cancelled because here we are getting V2 by V1 is equal to V3 by V4. So efficiency formula is 1 by minus T2 by T1. So overall, what you need to remember, efficiency of a Carnot cycle is 1 minus T2 by T1. Don't worry, in the next class I'll explain it again because they won't be able to understand. So you have to remember this formula only. Just remember 1 minus T2 by T1 is the efficiency formula, where T2 is the temperature of the lower isothermal process in which heat is lost, and T1 is the temperature of the upper isothermal process in which heat is gained. Correct? So this formula is important.
Okay.
Today let's end this because I know I'll have to explain it again in the next class. Okay, let's end it. No doubt, na? This you have understood properly?
Yeah.
Okay.